Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem: form partial differential equation from z equal to f of x plus ay plus phi of x minus ay by eliminating the arbitrary functions f and phi. So here we are given a relation. We are asked to form a partial differential equation by eliminating the arbitrary functions f and phi. Right? Let's see. Given z equal to f of x plus ay plus phi of x minus ay, right? Consider as equation number 1. So I'll find P, Q, R and T first, and later we'll decide whether S is necessary or not. Okay? Fine. Now let's partially differentiate 1 with respect to x, so that we'll get the equation involving P. Partially differentiating 1 with respect to x. Just apply dou by dou x on both sides of the equation. You'll get dou z by dou x. Okay. So here we are partially differentiating with respect to x, so we'll treat y as constant. Okay, and also here a is a constant. Fine. Partial derivative of f of x plus ay with respect to x is f dash of x plus ay into inner derivative, that is dou by dou x of x plus ay plus partial derivative of phi of x minus ay with respect to x is phi dash of x minus ay into inner derivative dou by dou x of x minus ay. We know that dou z by dou x can be replaced by the notation p. Just replace it by p, you'll get p equal to f dash of x plus ay into partial derivative of x with respect to x is 1 plus partial derivative of a constant with respect to x is 0 plus phi dash of x minus ay into partial derivative of x with respect to x is 1 minus partial derivative of ay with respect to x is 0. Since ay is treated as constant, okay, a is constant and y is treated as constant in this equation because we are partially differentiating with respect to x, right? Fine, this gives us p equal to f dash of x plus ay, because 1 plus 0 gives 1, 1 into f dash gives f dash, that is f dash of x plus ay, plus 1 minus 0 is 1, 1 into phi dash is phi dash, that is phi dash of x minus ay. Consider as equation number 2. Now let's partially differentiate 1 with respect to y. Partially. Now we are going to find equation involving q. Q is nothing but dou z by dou y, so that by partially differentiating equation 1 with respect to y, we'll get dou z by dou y, which gives an equation involving q. Okay, partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of the equation. If you partially differentiate with respect to y, then we have to treat x as constant here. Okay, you will get dou z by dou y equal to partial derivative of f of x plus ay with respect to y is f dash of x plus ay into inner derivative, that is dou by dou y of x plus ay, right, plus partial derivative of phi of x minus ay with respect to y is phi dash of x minus ay into inner derivative dou by dou y of x minus ay, right? Since we have a notation dou z by dou y equal to q, so we'll just replace this by q. We'll get q equal to f dash of x plus ay into partial derivative of x with respect to y is 0 plus constant a into partial derivative of y with respect to y is 1 plus phi dash of x minus ay into partial derivative of x with respect to y is 0 minus constant a into partial derivative of y with respect to y is 1. This gives us q equal to a into 1a, a plus 0a, a into f dash is f dash, a, f dash, right? A into 1a, 0 minus a is minus a. Minus into plus, minus, you'll get minus a into phi dash. Okay? Simply this gives us phi dash of into minus a, right? Here you are having plus. Plus into minus, minus a phi dash. Okay? And this is our equation number 3, that is q equal to a into f dash of x plus ay minus a into phi dash of x minus ay. You got an equation with p and an equation with q. Let's now find equations for x and not x, r, p, if necessary as also. Fine, now we need to find r, right? R is nothing but dou square z by dou x square. Now just you can write this as, we know that dou z by dou y can be replaced by notation p. So partial derivative of p with respect to x gives r. That is partial derivative of an equation that involves p with respect to x will give an equation with respect to, an equation that involves r. Okay, fine. Because this is the only equation that involves p and this is the only equation that involves q. Okay, fine. So in order to find r, we need an equation that involves p. So we'll pick the equation 2. Now let's partially differentiate with respect to, partially differentiate equation 2 with respect to x. Partially differentiating equation 2 with respect to x. Just apply dou by dou x on both sides of equation 2 in order to avoid mistakes. If you are really good at partial derivatives, just go directly. This gives us r. You can just directly write r, or you can write this as just replace p by dou z by dou x equal to, here we are partially differentiating with respect to x, so we'll treat y as constant and also a is constant, so we'll treat ay as constant simply. Okay, so partial derivative of f dash of x plus ay with respect to x is f double dash of x plus ay into inner derivative, that is dou by dou x of x plus ay plus partial derivative of phi of x minus ay with respect to x is phi double dash of x minus ay into dou by dou x of x minus ay. This gives us dou square z by dou x square equal to f double dash of x plus ay into partial derivative of x with respect to x is 1 plus partial derivative of ay with respect to x is 0 plus phi double dash of x minus ay into partial derivative of x with respect to x is 1 minus partial derivative of ay with respect to x is 0, right? 1 plus 0, and also we have a notation dou square z by dou x square equal to r, so we can just replace it by the notation r. You'll get r equal to 1 plus 0, 1 into f double dash is f double dash of x plus ay plus 1 minus 0 is 1 into phi double dash is phi double dash of x minus ay. See, this is the equation that involves r, so that I am calling it as equation r simply. Okay, there is no other reason. So we'll just name it as equation number 4. We got equation r. We got equation r here. Now let's find t. T is nothing but dou square z by dou y square, right? We can also write this as dou by dou y of dou z by dou y, right? We have a notation dou z by dou y q. This gives us dou q by dou y, that is partial derivative of q with respect to y gives t. Okay, now what we'll do is, in order to find an equation that involves t, we need an equation that involves q, right? And this is the equation that involves q. Now we'll partially differentiate on both sides with respect to y to get the to get the equation that involves t. Okay, we'll just partially differentiate equation 3, both sides of equation 3 with respect to y. Partially differentiating three with respect to y. Just apply dou by dou y on both sides of 3. This gives us dou by dou y of q is nothing but dou z by dou y equal to constant a into partial derivative of f dash of x plus ay is f double dash of x plus ay into inner derivative dou by dou y of x plus ay minus constant a into partial derivative of phi dash of x minus ay with respect to y is phi double dash of x minus ay into inner derivative dou by dou y of x minus ay, right? This gives us dou square z by dou y square equal to a into f double dash of x plus ay into partial derivative of x with respect to y is 0. Since we are partially differentiating with respect to y, so we'll treat x as constant here. Third, we'll get partial derivative of x with respect to y is 0 plus partial a into partial derivative of y with respect to y is 1 minus a into phi double dash of x minus ay into partial derivative of x with respect to y is 0 minus a into partial derivative of y with respect to y is 1. Since we have a notation dou square z by dou y square equal to t, let's replace it by t. You'll get t equal to a into 1 a plus 0 a into a square, f double dash of x plus ay minus a into phi double dash of x minus ay into 0 minus a into 1 is a, right? 0 minus a gives minus a. This gives us t equal to a square into f double dash of x plus ay minus a into minus a, or minus into minus plus a into a square phi double dash of x minus ay. Consider as equation number 5. Now observe all these 5 equations. So if you observe in t, you have a square f double dash plus a square phi double dash, right? If you can take a square common from these two terms, you will get a square times f double dash plus g double dash. Also we have f double dash plus g double dash, f double dash plus phi double dash equal to r, right? So using equation 4 and 5, we'll get the required result, that is the required partial differential equation. Let's see. We have equation 5. I'll consider equation 5. Okay, t equal to a square f double dash of x plus ay plus a square into phi double dash of x minus ay. A square exists in both the terms, so let's take it common. You'll get a square times f double dash of x plus ay plus phi double dash of x minus ay, right? And from equation from equation 4 we have f double dash of x plus ay plus phi double dash of x minus ay equal to r, right? So we can replace this term by r. Then this gives us t equal to a square into r, right? Or we can write a square r equal to t. Here r is nothing but dou square z by dou x square and t is nothing but dou square z by dou y square, right? Therefore a square into dou square z by dou x square equal to dou square z by dou t square is the required partial differential equation. This completes the problem, right? Fine. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.